We're now going to look at number 6 from the 2018 AP Chemistry free response. So if you have not done so yet, pause, work through this problem. You can find the PDF online. Just Google 2018 AP Chemistry free response. Work number 6, then come back, listen to the explanations. You can see the point distributions. So number 6, we are given this setup for a galvanic cell at 298 Kelvin. It has an electrode of silver immersed in 1 molar solution, chromium in a 1 molar solution. Those are the standard starting molarities for galvanic cell. Na, the student measures the voltage of the cell and discovers it is 0. So we got a dead battery. Identify the missing component of the cell and explain its importance for obtaining a non-zero voltage. And if we start looking here, we realize what's missing is our salt bridge. So A, once you recognize that, is pretty easy and quick to answer. Our answer would need to say that a salt bridge is missing. The salt bridge's importance is it helps to keep the charges of the left and right hand cells in balance. So remember, salt bridges will have a cation and an anion in it. They will migrate towards the cells that need them. So I had to talk about a salt bridge. I had to talk about how it maintains the charge balance of each cell. And if you did so, that was worth 1 point. B, the student adds the missing component and measures the cell potential to be 1.54 volts. As it operates, silver ions are reduced. So awesome. Even though we're not given the reduction potential of chromium, silver wins the reduction sweepstakes. Silver is reduced. Use this information and the information in the table above to do the following. Calculate the value of the electric potential for this half reaction. And notice, this is the reduction half reaction of chromium. Write the balanced net ionic equation and then calculate Gibbs free energy for the overall cell reaction in joule per mole of the reaction. So here we go. So we know that our overall cell potential is equal to the reduction potential plus the oxidation. 1.54 volts equals 0.8 plus our unknown oxidation potential. All we have to do is subtract, and we get that that is 0.74 volts. So the problem is that's the oxidation. This of chromium, this is the reduction of chromium. So our answer is negative 0.74 volts is the reduction value of chromium, and that was worth 1 point. For the balanced equation, we have our two reactions. I have already flipped the chromium. We are now looking at chromium being oxidized. We need to balance the electrons before we can combine, which means that we need to triple the silver reaction. That way our 3 electrons are canceled. So 3 silver ions plus 1 chromium solid yield 1 chromium 3 plus ion and 3 neutral silver solid atoms is our balanced equation, and that is worth 1 point. And to finish, Gibbs free energy. On our equation sheet, Gibbs free energy, one of the things it is equal to is negative NFE, or minus newt, moles of electrons, Faraday's constant, and our voltage. We had 3 moles of electrons. Faraday's constant is on our equation sheet, and the voltage was 1.54 volts. And if we multiply these out, we get negative 4.46 times 10 to the 5th joule per mole reaction for our answer. And that was worth 1 point to end this 4-point problem.